This is Calculus 2 class. We're gonna study integral for rational function. What is studied so far? We studied substitution method, integration by part, trigonometric integral, and trigonometric substitution. This session, we will discuss how to do integrate rational function. So first, you have to recognize when an integrand is a rational function first. Then we have to apply algebraic techniques, long division, factoring, simplification. Third one is we're going to use a partial fraction decomposition to rewrite rational function into simpler fraction form. So let's start with example. Consider two integrals below. First one is integral 2x plus 3 over x plus 1, x plus 2. This one is integrand is rational function. That's the one integral. Second is integral 1 over x plus 1 over x plus 2 dx. Which one you can evaluate in definite integral, guys? So, first one, first column. Can you do that? I don't think so. We cannot evaluate this rational function. How about second one? Second one, you separate each integrand. Now integral 1 over x plus 1 dx plus integral 1 over x plus 2 dx. Now, each fraction form, rational function, what is the antiderivative? 1 over x plus 1, 1 over x plus 2. You're going to use a u-sub, then you're going to find the antiderivative of each rational function. That's going to be ln x plus 1 plus c. Integral 1 over x plus 2 dx is going to be ln x plus 2 plus c. Now, we have ln x plus 1 plus ln x plus 2 plus c. That we find the antiderivative of second integral. By the way, two rational functions exactly same. I did partial fraction decomposition, change the rational function into the partial fraction decomposition. Then now we evaluate each rational forms. Let's get started this session right now. So, integral for rational function. Let's start point. What does rational function looks like? Rational function looks like integral fx over g of x dx. Integrand is rational function. So what do you have to first when you see rational function to evaluate? Guys, first, you have to check the degree of f of x numerator and check degree of denominator, that's the g of x. If degree of f of x is greater than or equal degree of g of x, you have to do wrong division first. Then you have quotient, you have remainder. That's you have to take a first step for rational function when you do evaluate. So let's have first example right here, guys. The first example is x cubed plus x over x minus 1. That's rational function. So check the degree with the numerator. That's going to be x cubed plus x. Degree going to be 3. Check the degree of denominator. That's x minus 1. That's degree going to be 1. So which one is bigger? Now, degree of denominator bigger than degree of numerator. First step, we have to take long division. Here is how to do the long division table right here. one by one, how we gonna do long division here? First is x cubed divided by x. That's gonna be quotient gonna be x squared. So now x squared times x minus 1, that's divisor. That distribute x squared times x gonna be x cubed. X squared minus 1 is x squared. Now you're gonna do subtract x cubed plus x minus x cubed minus x squared. So cancel out x squared minus x squared term only the second part. So negative x squared gonna be positive x squared, putting it down x there. So now x squared divided by x, that's gonna be x. Quotient gonna be x times x minus 1 equal x squared minus x. Subtract, let's cancel out. You add x minus x, that's gonna be 2x. So now 2x divided by x, that's gonna be 2. 2 times x minus 1, 2x minus 2. We subtract from 2x, that's cancel out. Negative 2 gonna be positive 2. Now, you know the which one is the quotient? Quotient gonna be x squared plus x plus 2. That's gonna be quotient. Remainder gonna be rx gonna be 2. That's gonna be remainder. So how gonna rewrite the rational form? So you're gonna write the rational form quotient plus remainder divided by divisor. So now we can rewrite this rational function inside integration. Now this is gonna be integral. Quotient gonna be x squared plus x plus 2 plus remainder gonna be 2 divided by x minus dx. That's you have to take first. When you see the rational function, check the degree. Degree of numerator bigger than degree of denominator or equal, not just greater. Greater than and equal, you have to do long division. Now, so I'm gonna integrate this rational function. Now we did the long division. We find the quotient x squared plus x plus 2 over x minus 1 dx. First part is using power rule. That's gonna be, you're gonna do it. So I'm gonna separate integration right here. Integral x squared plus x dx plus integral 2 over x minus 1 dx. You can use the power rule first part. Second part, you're gonna using substitution method. So I know integral 1 over x minus dx is ln x minus 1 plus c. Now, I can find the antiderivative both integral. First one is x cubed over 3 plus x squared over 2 plus x plus 2 ln x minus 1 plus c. That's how to do integral of rational function. So what you have to do, check the degree numerator denominator. Degree of numerator bigger than or equal to degree of denominator, you have to start with long division. Let's go to next one. Now, we have another rational function. This one is numerator, degree of numerator is 0. Degree of denominator 2. So degree of denominator is bigger, so we don't have to long division. Then how gonna do this rational function? How evaluate this rational function? So first step, guys, first step, you have factor. Factor first. Denominator you can factor. That's going to be x squared minus 5x plus 6 equal x minus 2, x minus 3. So I'm going to introduce partial fraction decomposition method for the rational function. Rational function you write this way. 1 over x squared minus 5x plus 6 factor of x squared minus 5x plus 6, that's the x minus 2, x minus 3 partial fraction decomposition give us to rewrite rational function this form. The numerator of x minus 2 gonna be a, numerator of x minus 3 gonna be b. So now what you have to do, we have find a and b value. Guys, the denominator is degree 1. Numerator, you have put the constant. So that's you keep in mind. That's the we call partial fraction decomposition. So now our question is how gonna find a and b value? So we have to do right side. We're gonna find the least common divisor to make the denominator is the same. So what do you have times first fraction right there? I'm gonna times x minus 2 both numerator and denominator. That's how I'm gonna do it. Plus second fraction part, second rational form gonna be I gonna times x minus 2 over x minus 2. Let's put together this rational form. You have denominator gonna be x minus 2, x minus 3. Numerator gonna be a x minus 3 plus b x minus 2. What do you have to do this partial fraction decomposition? We have find a and b value. Let's find the a and b value right there, guys. We have find a and b. So 1 over x squared minus 5x plus 6 equal a times x minus 3 plus b times x minus 2. That's numerator. Denominator x minus 2, x minus 3. X squared minus 5x plus 6 equal x minus 2, x minus 3. Denominator is same, so it should be numerator gonna be same. So 1 equal ax minus 3 plus bx minus 2. What you have to do, we find a and b. So you're going to plug in any number in the x, find a and b. There's one way to find the a and b, but there are different way find a and b, but I want to plug in the number to find a and b. So I'm going to pick the 2. So you cannot pick any number, but I'm gonna pick the 2 because when you plug in the 2, you're gonna see why. 1 equal a 2 minus 3 plus 2b 2 minus 2. 2 minus 2 is 0. So you have simply 1 equal negative a. So a gonna be negative 1. You find one value right now, a equal negative 1. Now, I plug in the 3 there. So when you plug in the 3, the equation 1 equal a3 minus 3 plus b3 minus 2. So 3 minus 3 is 0. So you have 1 equal b. So you find the b value right away. So how we did the partial fraction decomposition right there. 1 over x squared minus 5x plus 6 equal a is negative 1, b is 1. So now we have negative 1 over x minus 2 plus 1 over x minus 3. So I showed example of partial fraction beginning of this lecture. Why we doing the partial fraction? We want to integrate rational function. Now, rational function change into the partial fraction decomposition. Let's take integral both sides. Integral 1 over x squared minus 5x plus 6 dx equal negative integral 1 over x minus 2 plus 1 over x minus 3. I'm going to separate the integration there. So negative integral 1 over x minus 2 dx plus integral 1 over x minus 3 dx. Each integration, you can find the antiderivative. That's the right here. So this form of integration, we can use u sub. That's going to be ln function. Now, first one is negative ln x3 value x minus 2 plus ln x minus 3 plus c. I want to use property of log ln a minus ln b equal ln A divided by B. That's coming from property of log. So we can simplify this answer right here. Ln absolute value x minus c divided by x minus 2 because negative in front ln x minus 2. That's going to be final answer. This integration for rational function, we use partial fraction decomposition. Then we find numerator of each fraction. Then we do the integration. Let's have another partial fraction decomposition question. So this one is rational function. Degree of numerator less than degree of denominator. You don't have long division. So first we have factor denominator x cubed plus 2x squared plus x. So I take here a common factor x squared plus 2x plus 1. Then you can factor x squared plus 2x plus 1 gonna be x plus 1, x plus 1. We have 2x plus 1, that's gonna be square. Now we have x plus 1 square. So we want to use partial fraction decomposition. This factor of denominates a little different from previous example. So they have a square. When we have a square in the denominator, partial fraction decomposition looks like this way. So you're gonna put each denominator x plus 1, x plus 1 square. Denominate x plus 1, x plus 1 square. So x, you're gonna put the a, x plus 1, you're gonna put the b, but x plus 1 square is right there. You have put the x plus 1. Don't forget that terms. And then you have put the x plus 1 square. Now, numerator of x plus 1 gonna be constant because degree of denominator is 1. In the last part, x plus 1 square, but we're gonna put the constant in the denominator. That's gonna be partial fraction decomposition. Now, what you have to do, we have find a and b and c. Then we're gonna have this common divisor. So here is a of x plus b of x plus 1, c of x plus 1 square. So we want to make the same denominator. First, you have times x plus 1 square. Second, we have times x plus 1 to the both of numerator denominator. Last one is you just times x over x. Now, everything put together, denominator gonna be x plus 1 square. First term, x plus 1 square plus bx, x plus 1 plus cx. What do we have to do? We have find a and b and c. Let's find the a and b and c. So this is, we have equation right there. Denominator is the same. Numerator should be same. That's gonna be 5x squared 20x plus 6 equal 8 times x plus 1 square plus bx, x plus 1 plus cx. What do we have to do? We find the a and b and c. Plugging number is much easier and quicker way to find a and b and c compared to expand everything, guys. So you're gonna plug in any number, but you have picked wisely. I'm gonna pick x equals 0 because plug in the x equals 0, one term gonna be gone. Which term is gone? Last term. So plug in the 0 both sides. Left side is 6. Right side is gonna be a. X plus 1, you plug in the 0, that's gonna be 1 plus 0 plus 0, that's gonna be a equals 6. Very simple form you have. So you find the a value. Now, what do you want to plug in? I plug in x equal negative 1, then make x plus 1 equals 0. So I'm going to put the x equal negative 1. Then you have 5 minus 20 plus 6. A minus 1 plus 1, that's 0 square is 0, that's gone. B minus 1 plus 1, that's going to be 0, that's gone. Last term is negative c. So you have negative 9 equal negative c. You have c value is 9. So you already find A and C. Now what do you have find? B value. So you plug in any number you want. So I plug in the x equal 1. That's going to be 5 plus 20 plus 6 equal, when you plug in x equal 1, 1 plus 1 is 2. 2 square is 4a. Plug in the 1 there. 1 times 2, 2b plus c. But you already find the c value, a value. You find it. A value is 6, C value is 9, you plug in there, you have 31 equal 24 plus 2b plus 9. You can find the b value right there. 31 equal 33 plus 2b, b should be negative 1, guys. Now, you find the a value, b value, c value. Now, plug in the partial fraction decomposition. 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x equal a over x plus b over x plus 1 plus c over x plus 1 square. You plug in the a value 6, b value is negative 1, c value is 9. That's you have right there. 6 over x plus negative 1 over x plus 1 plus 9 over x plus 1 square. Now, we have to integrate both sides. So we want to integrate 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x dx. We find the partial fraction, that's going to be 6 over x plus negative 1x plus 1 plus 9x plus 1 square. We're going to put the integral separately. You have this form. 6 over x, integral 6 over x dx plus integral negative 1x plus 1 dx, integral 9 over x plus 1 square. I want to take out all the constant. Then you have this form. Now, can you find in antiderivative of each function? Yes. First one is antiderivative 1 over x gonna be ln x. That's gonna be 6 ln absolute value of x. Second is antiderivative 1 over x plus 1. That's gonna be ln absolute value x plus 1 right there. Now, third integral 1 over x plus 1 squared, that's going to be negative 1 over x plus 1 plus c. That's going to be negative 9x plus 1 plus c. Now, we're going to use property of log n ln a equal ln a n. Power move up to the exponential form. So now you have ln absolute value x 6 minus ln x plus 1 minus 9 over x plus 1 plus c. So ln a minus ln b, that's the property of log. That's going to be ln a minus b. You can simplify this answer ln x 6 power x plus 1 minus 9x plus 1 plus c. Okay, that's we did another partial fraction decomposition. Let's do one more example right there. Integral x plus 2 over x cubed plus x dx. First, you have factor denominator, guys. That's gonna be right here, x cubed plus x. Common factor is x. So you have x times x squared plus 1. Partial fraction decomposition is denominator of x squared plus 1 separately partial fraction. That's gonna be a over x plus bx plus c over x squared plus 1. So we separate factor of denominator x squared plus 1. Now you might notice something different. So first fraction is x. So you're gonna put the a in the denominator. numerator, but second is x squared plus 1, that's degree 2. You have put the degree 1 polynomial bx plus c. Now we have find a and b and c. We're gonna do the same process. Here is a over x plus bx plus c over x squared plus 1. We have make this common denominator. First fraction you have to times x plus 1, x squared plus 1, numerator denominate. Second is you have times x numerate, x denominate. Let's put together. Denominate gonna be x squared plus 1, numerator gonna be a, x squared plus 1 plus bx plus c times x. What do you have to do? We have find a and b and c. Now, let's find the a and b and c. That's the left side, x plus 2 over x times x squared plus 1. Right side, a times x squared plus 1 plus bx plus c times x times x squared plus 1. Denominator gonna be same. Numerator should be same. X plus 2 equal a times x squared plus 1 plus bx plus c times x. First, I'm gonna plug in x equals 0. So when you plug in 0, left side is 2, right side is a. So a gonna be 2. Now, I'm gonna plug in the 1, x equals 1. Left side is 1 plus 2 is 3. Right side is 1 squared plus 1 is 2, 2a. b plus c times 1, that's the b plus c. Now, you plug in the a equal 2, you have 3 equal 4 plus c. So b plus c gonna be -1, you find it. Now, so what is next? We need one more equation. So this time I plug in the x equal -1. You are curious what number you plug in. You plug in any number you want, but I just picked the specific number to equation simpler, make equation simpler. So x equal -1, -1 plus 2 is 1, -1 scale 1, 1 plus 1 is 2a, b times x, -b plus c times -1. So you plug in the a equal to here again, then you have 1 equal 4, distribute the negative times -b, that's gonna be b, c times -1, that's the -c. Now what do you have? -3 equal b minus c. So you have two equations, -1 equal b plus c, another one is -3 equal b minus c. We have solved the system of equation. System of equation gonna be b plus c equal -1, b minus c equal -3. How solve the system of equation? You're gonna use addition method. You're gonna eliminate one variable. I add two equations. So add two, C gonna be cancelled out. B plus B gonna be 2B. -1 plus -3 is -4. Now B gonna be -2. You find B value. You're gonna plug in one of equation. So I wanna plug in the first equation. First equation B plus C -1. I plug in B value is -2. -2 plus C equal -1. C gonna be 1. Now we finish partial fraction decomposition for this rational function. So what do you have here, guys? X plus 2 over x times x squared plus 1 equal a over x plus bx plus c over x squared plus 1. We find a equal 2, b equal -2, c equal 1. So now we have 2 over x plus -2x plus 1, x squared plus 1 right there. So now we take integration, guys. Integration both sides. So you have integral x plus 2 over x cubed plus x dx gonna be integral 2 over x dx plus integral negative 2x plus 1 over x squared plus 1 dx. Second part, we're gonna separate, guys. So can you see that? Integral 2 over x dx. Second integration, I separate to numerate. Negative 2x over x squared plus 1 dx plus integral 1 over x squared plus 1 dx. Now, let's find each antiderivative. Before we doing it, first I'm take a constant from first integration. That's going to be 2 integral 1 over x dx minus 2x over x squared plus 1 2 dx plus integral 1 over x squared plus 1 dx. You know the antiderivative first integral, you know the antiderivative third integral. So can you do the antiderivative second integral? That's gonna be right here. Integral 2x over x squared plus 1 dx, that's you're gonna do u sub, you're gonna be x squared plus 1, you're gonna be 2x dx. You can find the antiderivative ln x squared plus 1 plus c. What is antiderivative? 1 over x squared plus 1 dx. That's arctangent x plus c. Now, we found all the antiderivative of each integration. First one is 2 ln x. Second is negative ln x squared plus 1. Third is going to be arctangent x plus c. So let's put together of this log form. 2 is go up to the exponential. So exponent, that's going to be x squared. Subtracting the log, that's going to be division. So you have first one is ln x squared over x squared plus 1 plus arctangent x c. So what you did this section, guys, it's very complicated. We went through so many steps to evaluate rational function. Rational function is going to be a fraction where both numerator denominator polynomial. So before you start integrating, first you have to check if log division is needed. Degree of numerator is greater than or equal to degree of denominator, you have to do long division. So after long division, you have to do partial fraction decomposition right there. Break the complicated fraction into simpler fractions that are easier to integrate, which meaning is you have factor denominate, then you have to do partial fraction decomposition to evaluate rational function.